Hello everyone, myself Ashit Desai, Assistant Professor, Sharad Institute of Technology, College of Engineering. Today we are going to discuss the integration of additive manufacturing with IoT. So this is for smart manufacturing approach, part second. So already we discussed the Industry 4.0 in that the main component of the system is IoT, and then we are converting with this in the AM, that is about additive manufacturing, because the additive manufacturing is basically utilized for the which is forming for the complex geometry, and whenever the complex geometry is there we can suggest the additive manufacturing over here, because in a manufacturing era there are two manufacturing methods are there: subtractive and additive. In subtractive manufacturing there is a lot of wastage is possible, but in case of additive manufacturing is required less wastage. So that is why we are going to discuss the integrations of additive manufacturing, because if you say additive manufacturing there is some reason we are integrated with IoT. So why it is integration will required, so this will get the information from by the this case study. So first of all, we discuss this case study with one lab, that is Bamboo Lab A1 printer, that is A1 mini printer, which is IoT powered with 3D printing. So here there are different components is associated with 3D printing. So this is called as a nozzle, and the one indicate that is about filament hub, which is filament will be fitted, and then the printing will be takes place. Same way, that is tool head, which is present at the point, so which can movable from to and fro, as well as it can move in x and y directions. Then x linear rail also is present, so whole assembly we can move from this x axis. Then purge vapor, this is for the removing of excessive materials. Then hot end silicon sock, so it is for the heating purpose, because thermocouple we can say used over there for temperature measuring, and then we can send the data to the as a, on a panel, and accordingly it can be adjust the temperature. Then next about build a plate, so where the object is printed over here. Then it is about heat bed. Then it is about y-axis linear rail, so it is about moving in a linear way, that is in y-axis. So that is a formulation for x and y. Then getting a z direction also the possible for that. That's why this is the column which is useful for getting the height of the job. So this is about the helpful. Then next is this is cable for attaching for the nozzle. Then camera is fitted over there, so this is remotely we can operate the condition, that is why the camera is provided. So actual condition, what objects that where you can identify the status of object by using this camera. Then z-axis rail for whenever the first layer is come up, then second layer, third layer, so at that time layer by layer is created, so this rail will be goes upward side. So this is why the z-axis linear rail is present over here. And then we are associated with part cooling fan, so whenever the excessive temperature is built up in a nozzle, so that time we are getting the less more heated, so that's why we can get the cooling is required, so cooling fan is provided as a part of nozzle. Then next this whole assembly is called as nozzle. Then touch screen is available for the changing of your component or selecting of your component. Speed changes we can do with the touch screens. Then AMS port, so we can communicate with that card, that is memory card, we can, that is why provided AMS port. Then that is about SD card, so also providing with this note. So this is about the capability we can provide as a 3D printer. So this is use we are use of different sensors and different actuators we can use over there, and the main power, that is real-time database we can getting from the system. Then we are using the, first of all we discuss these three axes, that x rail is possible through left and right, so x-axis movement, and then this is for the nozzle. Y-axis, so it is getting by the that is about y-axis the given by the that table. Then z-axis is given by this column, so it is up and down. So then and then only component the formulation which takes place. Then accelerometer is installed for the on the tool head to monitor the tension of the force which is created in x-axis and y-axis on belt, so that can be fixed by the accelerometer. According to that speed we can that can be managed by the accelerometers. Then eddy current sensor we can use for the measure the hot end, and then we are creating the flow rate as possible as way, and then real-time pressure reading is there. So this is the important structure we are discussed here. So this ensures the work together to ensure the precise movement and extrusion, contributing to the A1 mini project. So this is A1 mini high speed integrated high quality 3D printing capabilities. Then this is about tool head module, and this tool head module is one of the key components of the A1 mini. The tool head module mainly consists of the following components: hot end assembly, then extruder, then unit, that is cutter unit, and filament hub and filament sensor. So these can be utilized for the tool head, which is useful for the excessive material is there, so we can use the cutter. Extrusion unit is there, so whenever the heating of the material is there, after that it can be form that melted part, so it can be dropping for the laying purpose, so that is useful for the extrusion unit. So these different elements we can use there. And the filament sensor, the filament is present or not, so that can be determined by the filament sensor. So this is whole assembly which is present in a tool head module. So this kind of actions we can do with the tool head modules. Then next is about filament module. Then magnet is present over there, then filament engagement hall sensor is there, so that level how much the present over there. The cutter hall sensor is there, then extrude hall sensor is there. So different sensors we are using there. And this module is consisting with multicolor printing. So here we can get the multicolor printing is possible over here. Also the filament engagement hall sensor to check the for filament enlargement, and when there is excessive resistance during the filament hub is pulled down and magnet to move closer to the hall sensor and triggering the filament enlargement alert. So this kind of actions we can do with the this type of magnet, and then we are getting the extruder hall sensor. So this combinedly we are having in a tool head modules. Then nextly we are going to discuss the cooling system. So whenever the maximum heating is there, so at that time we can cooling fan is required over there, and that for the rapid cooling we can get the rapid cooling, we are getting the fast rate efficient cooling will be get, and then the fast printing will be possible, so that can be provided in a cooling systems. Then touch probe detection, that is by measure the force exerted on the head end, and which is used to be detect the contact between the road tool head and the head bed, combining this up and down movement of the z axis. And then the A1 mini can directly measure the height of specific point. So this can be measured by the touch probe detection. So we get the how much the completion is there and how much area will be occupied by the component, that can be assisted over by using the tool probe detections. The next is about camera. So it is useful for the detection, which is how many support viewer is there, and real-time monitoring of prints you can avail with this. So record the videos, and which is save in that micro SD cards and generate the time lapse video. So this can be possible whenever the night vision it is not equipped with night vision, but camera will be module as auxiliary light to eliminate the print. So this is also possibility in the cameras. So this is the case study for the whenever the integration of IoT is there, so that can be possible, changes will be possible. And then what is the healthcare industries of industrial things, so that is also possible. So whenever the this whenever 3D printing is used in a IoT, so design the module, then after that check the feasibility, choose the right process and right material. After that IoT enabled MRI machines can be store the high resolution images and then can be pointed in a 3D model. So that can be enable the sensors and the connect to the IoT track functioning by analyzing data. So every time there is no required the person, whenever we getting the data from the MRI scan and MRI machines, so after that it can be modeled in a 3D component, and then we can design the component and then we can check the feasibility. So there is no requirement in that, so we can easily manufacture the component, that is why 3D printing. So every time there is a requirement of the real-time data and the different sensing data, and then we can component really customize. So this is about the advantage point of view we can take the into considerations. Also we are in healthcare industry, also we can surgical tools are presented also, they can make in 3D printing, and that can obtain greater precision also. So this is about the kind of actions we can take away for the system. After that we can go to the conclusion. So IoT transform the 3D printing into smart, automated and optimized process, then reduction in the errors, quality improvement, and enable the operation remote operations. Then future advancement will be integrated with AI and blockchain and digital twins. So these are the main area we are focusing nowadays in a IoT 3D printing. So it is integration of 3D printing. So mainly various challenges is also faced in that conventional way. So that can be solved in a IoT 3D printing. So this is about the main motto of the system. So after that we are some part we'll discuss over here, that is about industry to 5.0. So whenever the journey of Industry 5.0, human touch revolution is there, high demand of individualization is required, mass production and customization to mass personalization. So every day the need of the person to person is vary, and that can be mass personalization, and that mass personalizations we can manufacture. So example is the boot. So this shoes we can manufacture over here, and then different boats are there, we can say robot. So that robot is there for we can say that is for the serving purpose in hotels, and so that anytime the railway tracking or in case the airports to give the information, because every time the need of the data from the personal to person it should vary. So that can be managed in a industry 5.0, that is called as mass personalization. So here we are, the industry 4.50 is the main challenge for the mass personalization, then collaborative robots, waste elimination, sustainable machines, intelligent process, renewable energy for operation. So these are the area we are required, because high demand of intelligence are more, and that should be required in the industry 5.0. Then this is about the discussion about the industry 4.0 and how it can be aware about journey of industry 5.0 in the next incoming days. So this is about the content which is delivered in this content in this session. Thank you.